All right, Lily, where are you? Am I good? All right, thank you. Well, thank you, Ryan, and thank you, Jake. Really hard to follow a communications scholar in providing keynotes, especially when you're an introverted engineer. So I'll look at Sigi's shoes as a sign of my extroversion. Like I said, good morning. It is generally an honor to be back here in DevCon in 2026, here in Salt Lake City, my home. 30 years ago, my family moved to this valley, and actually it's 30 years ago next week. The Oakers, the mountain range across the valley from us, had snow almost all the way to the bottom, and that snow lasted through July. And talk a little bit about that. You'll hear more from James later about the crisis in the Colorado Basin, and you'll hear more from Rob about the impacts on the Great Salt Lake. But when we started Cairo, many of us hoped that we would create something that would be meaningful and accelerate research operations in hydrology. But I think few of us did not fully appreciate how quickly the operational need for this work would become intensified. Where's my slide clicker? There we go. So today I want to talk about what I believe are three defining water challenges facing the country right now. These are not theoretical future challenges. These are operational realities. These are the kinds of realities that water managers, our emergency management community, reservoir operators, and forecasters are dealing with every single day. I want to argue something fairly directly. The tools emerging from Cairo, from this august community, over the last very short 5 years, are not simply academic advances. They are becoming foundational infrastructure for how society manages water risk. For decades, operational hydrology largely revolved around deterministic forecasts at river gauges. And those products remain very useful today. They remain operationally familiar, but increasingly they are insufficient for the decisions society now needs to make. Emergency managers do not simply need to know a river stage, they need to know which neighborhoods will be underwater. Reservoir operators do not simply need a forecast hydrograph, they need probabilities for operational risk. Water managers do not simply need a seasonal outlook, they need to understand the uncertainty in supply, timing, and consequence, much like how the Colorado Basin River Forecaster, which I hope some of you at least got to see in person yesterday, serves our stakeholders today, and more on that throughout the workshop. The operational reality is that what we are now facing and forecasting is a non-stationary world. And the core issue is no longer simply prediction. It is decision support under uncertainty. Let's start by taking a look at the drought, with the current drought across the country with the drought monitor. Right now, large portions of the West are in drought, pretty significant drought. Parts of the southern Ohio Basin are stressed, and across the Southeast, we are seeing communities experiencing persistent hydrologic dryness not seen in decades. And importantly, this is not simply a prediction problem. It's a systems problem. It is a problem of snowpack uncertainty, soil moisture depletion, groundwater stress, reservoir storage deficits, runoff timing uncertainty, and agricultural demand. When you talk about drought operationally, and what we are really talking about is the uncertainty surrounding future water availability. In many Western systems, the uncertainty is now structural. The old assumption was that hydrology would oscillate around some recognizable historical baseline. Increasingly, that assumption is failing. And nowhere is this more obvious than the Colorado Basin. I don't want to steal James's thunder. He has a lot more plots, a lot more detail. The Colorado Basin is one of the clearest examples of why operational hydrology is inseparable from economics, governance, and risk management. The basin is under extreme pressure, not just from one dry year, not just from one bad snow season, but from a multi-decadal imbalance between supply and fundamental demand. And now is a time to beginning to challenge some of the fundamental institutional assumptions of Western water management, including prior appropriation. I contend that this year will be an unprecedented year in the legal system as we look at prior appropriation across the basin. The federal system is broken. I say that with all due respect to many across reclamation and parliamentary who are trying their best to solve this, and the states are in battle between the upper basin and lower basin. For over a century, Western water law has largely operated under the assumption that the basin would continue to provide enough reliability for those allocation frameworks to remain workable. They are not. Operationally, what happens when water becomes less reliable? What happens when forecast ensembles indicate increasing probabilities that historical supply assumptions no longer hold? This is where operational forecasting becomes deeply consequential, because now the question is not simply what is the runoff forecast. The question becomes, what is the probabilistic distribution of water availability? What are the risks? What risks are acceptable? What operational decisions are economically defensible? This is a fundamental difference. This is exactly why probabilistic water prediction matters. Now let's move to the opposite end of the spectrum. The image behind me is the atmospheric river from December across portions of the Northwest. We saw this across a period of weeks in early December. What makes many of these events operationally difficult is not simply the rainfall totals, relatively predictable, but it is the hyper-localized rainfall extremes that can now overwhelm communities between traditional communication paradigms when they are not fully characterized by consequential impacts. And this exposes one of the most important limitations in traditional hydrologic forecasting. Hydrographs describe conditions at a point. Flood impacts occur across landscapes. This distinction matters enormously because the public does not experience a hydrograph. They experience flooded roadways, destroyed homes, overtopped bridges, evacuations, and isolation. So I believe, and those of us in our program fundamentally believe, that flood inundation mapping represents one of the most important operational advances in modern hydrology, brought in no small part by Cairo. If you don't believe me, stay tuned Friday morning. Derek Giordino, our FIM lead, and Carson Pruitt, his partner in crime, will convince you in a very compelling way that we have entered a new world in flood warning and communication. Flood mapping changes our operational conversation. It translates flow into consequence. It allows us to move beyond asking, what is the river stage? Instead, we ask, what is going to happen across this community? This is entirely different operational capabilities. Importantly, it aligns hydrologic forecasting with how people make decisions. Transportation departments do not close roads based on hydrographs. Emergency managers do not evacuate neighborhoods based on hydrographs. Communities respond to impacts. And FIM is not only visualization, it is a direct translation of hydrologic science, societal decision-making, and two key components of Cairo. It is impact and consequence. And I would argue this concept that translating hydrologic uncertainty through these impact-based decision support services is where the future of operational hydrology is heading on the extreme upper echelon side. This brings me to an essential call for action. We must move beyond ensemble-based water prediction. We must move to ensemble-based predictions across all hydrologic forecasts, not just flooding, everything. We see this in water supply, we see this in reservoir operations, we need to see more of this in our drought response, navigation, hydropower, and agricultural demands. Because the reality is this: most major water decisions are already probabilistic decisions. The operators know this, the Army Corps of Engineers knows this, the Reclamation knows this, utility companies know this, and the insurance and reinsurance industry knows this. The problem is not that operational hydrology has not always been fully, the problem is that operational hydrology has not always been fully aligned with this reality. And this brings me to the concept of actuarial hydrology and why it becomes important. When we discuss uncertainty, we often consider it as a frame of forecast spread. But operational stakeholders increasingly need something much more specific. Forecast-informed reservoir operations, or FIRO, which we'll hear more about, is one of the clearest examples of this translation. FIRO ensembles are not simply evaluated because they show uncertainty. They are used to estimate the probability of exceeding operational thresholds. And these probabilities are evaluated against risk tolerance curves. That is actuarial reasoning, and it is distinct from simply spread in a forecast. Because now the forecast becomes directly tied to economic defensible operational decisions. The questions become, what is the probability of a consequential event? What are the consequences if it occurs? What operational decision is justified by that risk? And honestly, this is, I believe, where operational hydrology is heading. So here's the hopeful part of the story. This is why Cairo matters. 5 years ago, many of these tools required to support this transition either did not exist operationally, or as Steve said, they existed in a garage someplace, maybe in Silicon Valley. Or they existed in fragmented research ideas, not bounded by a cohesive community like Cairo provides today. Today, Cairo has fundamentally transformed that landscape. Here's what we have. We have a next-gen framework. We don't have a next-gen model yet. We have a next-gen framework. We have next-gen in box. We have a cadre of people who are learning about that in this conference today. We have distributed modeling. We have advances in data assimilation. We have differentiable hydrologic models. We have machine learning integrated across all process models. We have large-scale hydrologic approaches, improved calibration methodologies, expanded ensemble capabilities, operational FIM, and a cadre of social scientists or communicators to ensure that we hit the mark with our stakeholders. Perhaps the most important thing that we have today is we have a community capable of integrating these ideas into operations, and that's what matters. It's the integrating of these tools that you'll learn about today and this week into something that transforms the future of water prediction. Research operations is not simply about better science. And I fundamentally believe this. It is about creating operational trust. The forecasters must trust the system, the operators must trust the probabilities, and the stakeholders must trust that the research community, the stakeholders must trust the consequences being communicated. And that trust only emerges when the community, the research community, and the operational community, and the stakeholder community evolve together. Cairo, I fundamentally believe, in a very short 4 years, has created exactly that ecosystem. As you look forward towards something much larger than traditional hazard or resource forecasting, we're moving towards comprehensive water prediction. A system where atmospheric ensembles from systems like the Warnow Forecast or Rapid Refresh Forecast System feed hydrologic ensembles into community hydrologic prediction software used by the river forecast centers, our new next-gen framework, and as warranted produces FIM or other probabilistic consequential-based information. So this is a system where uncertainty is propagated continually from the atmosphere to the watershed to the consequence. A system where flood impacts, water supply, reservoir operations, and drought outlooks all emerge from an integrated probabilistic framework. This is not science fiction because of Cairo. This architecture is the future and is beginning to exist right now. I guess on June 8th, we'll hear some interesting news from Steve, but I will say the future is exceedingly bright for the next 5 years. Let me close with this thought. The grand challenges before us are not simply about improving forecast. It is about making uncertainty operationally usable. Drought, water scarcity, extreme flooding, everything in between. And these are not isolated problems. How many communities across the country face this within one water year or across water years? I would argue that almost all of them do. Define for me what a stable ecological hydrologic system is in this country. I want to move there because I haven't seen one any place I've lived in the last 47 years of my life. The good news is that the tools exist within this community to begin to build the future. First 5 years of Cairo have been incredibly important. We've elevated technology readiness levels to the 4, 5, 6, and 7 level. As we look forward into 2027 and beyond, I think we'll see the elevation, the research operation really hit that operational stride. But it's not simply new models. It's not simply new algorithms. It's not simply new social science or expanded integrated social science. The beginning of this operational paradigm is for water prediction in the United States. It's one that is probabilistic, it's impact-based, it's risk-informed, and I think the most important thing for me is that it's bounded by a community. We call it a Cooperative Institute for Research Operations in Hydrology, and that's what it is by law. That's what it has been in the CI handbook. And that's an interesting construct. It's a construct that is probably close to 25 years old. I would challenge all of us that the C in Cairo probably stands more for community than it does for cooperative. And of course, you can't have cooperation, or you can't have community without cooperation. So I am extremely excited about what comes next. I'm excited about the students, the graduate and undergraduate, postgraduate students that are here today learning about new tools. I challenge you to be curious. Look at these individual building blocks of next-gen in a box, FIM, the hydroinformatics, the work that George will lead in discussions about social science, and stitch them together in ways that we haven't even thought about it. Think outside of the box. Think towards the future. Remember that these challenges that we began with are only going to get worse. Thank you.